Okay, so here we are discussing nucleophilic substitution reaction. The reaction between a strong nucleophile. A nucleophile is a species that has a pair of electrons, that's an electron pair, or has a negative charge. A nucleophile will replace a halogen from a haloalkane. So this X here represents a halogen, and then we get an alcohol, and then the halide ion. Now, there are two types of nucleophilic substitution reactions. We have SN1, that is a unimolar substitution reaction, and we also have SN2, that is bimolar substitution reaction. SN1 substitution reaction favors a tertiary alkyl halide, as you can see here, while SN2 favors a primary alkyl halide. So this is the mechanism of SN1 substitution reaction. The alkyl halide is dissolved in a polar solvent. When a polar solvent is introduced, there is a formation of carbocation. So we see that there are two steps here. A carbocation is formed. So this is a carbocation, and we have a halide ion. Now, on introducing the nucleophile now, there are two possibilities. Here in the first one, the nucleophile will attack from the front. Okay, so we have a 50% retention of the original configuration of the alkyl halide. And in the second occurrence, it will attack from behind. So there will be 50% inversion of the configuration of the alkyl halide. So remember that this unimolar substitution reaction is a first order reaction, so it depends only on the concentration of the alkyl halide, doesn't depend on the concentration of the nucleophile. Now we have the bimolar substitution reaction. This case now, of course, we have this alkyl halide. It has a permanent dipole in it because this halide has a negative dipole. The carbon has a negative dipole because of the differences in their electronegativities. Okay, so when this nucleophile is introduced, this nucleophile cannot attack this halogen halide because halide is also a nucleophile, although a weak nucleophile. It can't attack it directly. So this reaction cannot proceed like this. Instead, this is what happens. The nucleophile will attack this halogen indirectly by attacking this hydrogen, okay?